Hello. Hello.
Hi,
Good
Mr.
morning.
Hey,
Okay.
good evening, Mujano. Good
Oh,
morning, Uday.
thank you.
Hey,
Okay. Okay.
good evening, Vijano. Good morning,
Okay.
Suji.
Okay. Okay. So I am also busy with other tasks for my examination. So that's why yesterday I will not take the class. But today my
Okay,
examination is held. So that's why now I'm free available. Okay. Okay. So now we'll
Okay.
start our today's class. So basically today I think it will be second days. Okay. Second days is not completed for the previous class. It's not completed. We'll start
Correct.
from the second days today's class. So let's go. Okay. And did you get the recorded video class? Both of you get the recorded video class. I did not send you the link, but I think you can get the in your email address. When I give the access privately through my YouTube channel, you can get the access you can get the message in your inbox, email inbox. Did you check it?
I haven't received email, but I think you put something in the WhatsApp last week, right?
Okay, okay. So I also put that and also send
Yeah,
the
yeah,
link. Then also better. Then you can simply
yeah,
go to
yeah.
this link. Then you can easily identify all of those recorded class. So basically,
Please
we
send
can
the link.
create the playlist. In this playlist, all of those recorded video class will be stored in here. Okay, just you can
Okay.
simply log in and you can see it.
Yeah, that will be easy.
Okay, okay. So let's go our today's class. Okay, so now can you see my screen? Is it
Yeah,
visible?
it's
Okay,
coming up.
okay.
Yeah.
Thank you. Okay, so let's go. Okay. So I think previous class we try to discuss only for the filtering and displaying the satellite image, Landsat image. How you can easily filtering, okay, and displaying the satellite images from the Google Earth Engine platform. This part will be covered for the previous class.
Yeah.
Okay, and also satellite image is also available. Let us try to discuss about that. And then band combination, I can easily use the different types of band combination, then export the satellite images and import, filter, reduce, clip, display the data in Google Earth Engine platform. So mainly this part we try to show you that how you can easily work with the Modis NDVI. Modis NDVI data, how can easily import, then filter, then reduce and also clip on your study area and display the result. Okay. Not only for that, we are also displaying the result in our ArcMap software. Okay. So suppose you want to download the TP images and final product, you can easily make the map this type of. You can see this is the NWI map. Mainly it's showing the water index. So this map we can just simply download the TP image. Just simply download the TP image from the Google Earth Engine platform, and then further process we can using here the ArcMap software. Not only for that, any types of map in here we can easily use here for that. Just a minute. Yeah. So this type of map we can easily create, and in Google ArcMap software also using that. Okay, you can see NDVI map of Dhaka city. Okay, so this type of map we generate from the Google Earth Engine platform. But for presentation, we are just downloading the TP image from here and make the further analysis in ArcMap software. So you can see LST map of Bangladesh year of 2023. Okay, this is the LST map we are created. Okay, so all of those things we can easily create it as a TP image in Google Earth Engine platform, and final product we can get from in ArcMap software.
Yeah.
Okay, the final product you can get it from the ArcMap software. As also you can see the NDVI map. Okay, Ghana NDVI map. So any types of map we can simply download as a TIFF format. Okay, and further analysis for displaying this map we are using here that ArcMap software. And how we can easily create this type of map, I also try to show you that. Then we are easily using this ArcMap software and easily create this map. Okay, for your research paper or your presentation work, we can easily display the result. Okay, okay. So then in time series chart of NDVI from the Modis data. So today I also try to discuss about that how can easily create the time series data. and from this time series data, how we can easily make for the trend analysis. Suppose you want to get the 20 years data for any specific region of NDVI. So now you want to display the result about the trend. What is the trend for this region? It will be high trend or low trend. This type of result we also try to show you that. And also export any shape file from the Google Earth Engine platform and calculating any indices from the satellite images. Okay, so let's go about that. So first of all, we already know about that we can easily get all of the things from the Earth Engine public data catalog. So this is our Earth Engine public data catalog. We can simply go to this link or simply go to the code editor and simply browse data catalog. So then it will be appear at all of those Earth Engine public data catalog. So first of all, I will try to discuss about the time series chart. Okay, different types of time series chart, and from this time series chart, how we can easily calculate it, the different types of analysis such as trend line analysis as well as other parts. How we can easily create the very beautiful chart in Google Earth Engine platform. Okay, so basically in this time, suppose I want to work with for the MODIS dataset for creating the time series chart. Then also show you that Landsat and Sentinel, both of satellite image, how can easily create the time series chart. Suppose you are using the Landsat image and make the NDVI, and then you want to calculate the time series chart. You want to make the use the Sentinel imagery and want to make the suppose NDVI, and you want to make the NDVI time series chart. Or not only for that, any types of time series chart, how you can easily create it. I also show you that. Okay. So first of all, try to show you the MODIS, then show the Landsat and Sentinel, both of image, how it will be work. And time series chart, all of those time will be same. Suppose I want to show you this time series chart, surface temperature. You can also apply the same process other data set, surface reflectance daily global. Also you can see the Thera anomalies fire daily global. So MODIS is the same. This is creating the time series process is the same. Okay. Suppose you want to work with the leaf area index. I want to show the leaf area index, but using the same process, you can also apply the suppose MODIS land surface temperature, also NDVI. So any types of time series data we can easily create from here, and I can easily get the result. Okay, so let's go about that. Suppose in this time I want to create this time series chart about this suppose which data. Suppose I want to work with for the suppose LST. So I want to display the LST. Suppose you can see land surface temperature, this data set I want to use, and then make the time series chart for any specific region. Okay, so this is the LST data set. Okay, I simply click on here. I can got all of the information. First of all, you can see data set availability from 2000 to 2022. Okay, and also you can see that provide that new data set. Okay, so when you can get this type of question about that, you can simply click to the new data set. Okay, because in this time this data set is not update. Okay, but when you want to need the update data set, then you must be go to here. So now I can get the update data set. You can see 2023-06-02. Okay, so now I want to use the data set and try to make the time series chart for any specific region. Okay, so let's go about that. So first of all, what can I do? I just simply import the image collection. This is my image collection. Okay, it is stored.
So one quick question.
Yeah, please.
Question here. So for the surface temperature, do they have separate sensor and the band for that? How they get the surface temperature? MODIS?
Okay, so in this time, this is the MODIS product. So basically this MODIS product, it ready-made data set, but I also show you the Landsat, how we can easily create this type of surface temperature calculation in the Landsat part. But in the MODIS, they are already create, you can see they are already create the LST. It already created. Unit is the Kelvin. So in this time we are using the ready-made data set. But further class, I also show you that how you can easily work with for the Landsat imagery and create the LST or monitoring the LST. Okay, so this part also covered. In this time, you can just, it is a totally ready-made data set. Just we are using and try to make the time series chart about that. And how they create this data set, you can see. Basically, this data set provides an average 8-day land surface temperature at a kilometer grid. This 1200 into 1200 kilogram grid. Okay. And each value in this is a simple average of all the corresponding MODIS LST pixel collected within the 8-day period. Okay, so in this time which pixel value you can get it the 8-day period average value. Okay, so they are already create this data set. In this time we are just using this data set and try to make the analysis, but I also show you that how can easily work for the Landsat image also. Okay, for creating this type of analysis.
Okay.
Okay, so now I simply import the data set. So first of all, I simply copy that because this data set is totally stored in here. So just I simply copy and paste and give a variable name. You can use any variable name. Suppose I put the variable name is that modis LST. Okay, so now my full image collection, this is my full image collection, is stored in this variable. Okay, in this time we already know about this image collection is a band. What is the band name? So I call the band name. I want to make the time series chart for the LST. So just I simply copy the LST day 1 kilometer this time this band and then paste here. I simply use a function select function, select and select this band. Okay, suppose in this time I want to make this time series chart for a specific time period or a specific time period, such as I simply use a function filter date function. Okay, so filter date function mainly filter the specific time period. Okay, I simply put the time period such as year of 2000, suppose 2010, suppose 1st January from suppose 2022 December 31. Okay, so this is my observation time period. Okay, so now let's check about that image collection, how many images I am to get. So I can check about that. You can see how many images are available. Simply copy and then simply use the size function. So now it is check the result about that. We can get total 598 images. Okay, so this is my image collection. Okay, so mainly you can see when you create the time series chart, your first argument is image collection. Okay, you can check. I simply put here this is the function about the creating chart, UI chart dot image dot series. Okay, you can see what is the first argument. First argument is image collection. Okay, so not only for that, when you want to create any types of time series chart, first of all you have to check how many images have in your image collection. Here I can get total 598 images. Okay, and it is stored in this variable. So I make a dictionary. So I put here the curly bracket start and also put here this curly bracket int and then put all of those keyword and key value one by one. So first of all, image collection. So image collection is that how many images are available. 598 images is available. So now let's check where the variable, which variable stored this number of images. What's the variable name? This variable name is that modis LST. I simply copy and paste here. Okay, some people also do a big mistake in here. They are just use here the reduce function. Suppose when I want to use here the reduce function, suppose I want to calculate the EE dot reducer dot mean. I use this function. When I apply the mean function, then it not a image collection. Okay,
Just a single image.
Single image, yeah. So then it's not a image collection. Then it will be single image. So single image is not possible to create the time series chart. Mainly time series chart when we create, we need to use the image collection. Okay, so without this reducer, we need to, which I can get, it's the image collection. So this is the image collection. Many people, they are put here the reduce region and then use this variable name in here. Then they did not get any types of chart. They get the wrong. Okay, so when I put the mean, then it will be not a image collection. It's showing a single image, average image, pixel value image. So in this time I not reduce that. Okay, because I need the image collection. But when I display this image on my map, then I need to use the reducer. Okay, so just I get the 598 images and then it will be stored in this variable. I simply call it and paste here. Okay. Then region is that which area you want to make this time series chart, for which area. So in this time, suppose my area is that suppose Dhaka city. I simply put the Dhaka city and put this name such as RY. Okay. And region in this time, put here this region is that, sorry. Okay. Okay. Region I simply put here the RY. Okay. Then it also done. After that, I also need to put here the reducer. In this time, I want to use at the e reducer.min. I want to get the 8 days average pixel value for creating this time series chart. So use at the e dot reducer dot min. Now it create the chart about that 8 days average pixel value. But when you want to put here the max, then it create the chart 8 days maximum pixel value. When you are put here the mean, then the chart will be created for the minimum pixel value of LST. Okay. Then scale. Scale is the resolution of this satellite image. In this time, 1 kilometer all is the 1000 meter. Yeah. So I check the resolution from here. You can see, yeah, 1000 meters. So put this. The next property. So X property default. We are using here the system time start. System time start. So this is my all of those things for creating the chart. Okay. In this time, okay, so it will be ROI. Okay. Same variable need to use. I use the uppercase. Also need to hear the uppercase because it's case sensitive. And then I simply all of those things store it in a variable. Suppose this variable name is that chart. Okay. Now let's check about the time series chart. Simply use the print. Then call the chart. So it now generating the time series chart about that. Okay, but the chart is not meaningful. In this time, you can say how much value I want to get. 40,000, 50,000, 60,000. Okay. In this time, this result I got look like that because this pixel value is not represented. Okay. So for the modis, we always put this, we can take all of those modis data has a scale value. All of those modis data, not only for the LST. NDVI, you already know about that. NDVI also has a scale value 0.001. In this time, we also get the scale value 0.002. Okay. So this type of scale value we can got. That's why we need to reproject this pixel value. And how I can reproject? I can get total 598 images. Just I simply multiply with my scale factor 0.02. Then it will be reprojected the scale value and I can get the accurate value. Degree will be Kelvin. But this Kelvin we can easily change into the degree Celsius. Okay. So let's go about that, how we can easily create. So for that, okay. So for that, what can I do? I need to reproject it. There are a lot of way for creating the reprojected. So in this time, I just simply use a function in here. Suppose, okay. So I simply use a map function in directly. I simply put here the map function. Okay. And then call this function keyword. In this function keyword, take a element name and put the curly bracket. In this curly bracket, just put here the return this image, multiply, sorry, it will be image multiply with scale factor 0. It will be 0.02. Okay. As well as I also need to convert the unit. Suppose degree Celsius. Just simply use here the subtract with 273.15. Okay. And these properties I just need to copy. So use here the copy properties. So copy properties, then apply it from image and mention here system time start as well as system time end. Okay, so now it will be projected. In this time you can see, if I want, I can take the another variable and write this code, but in this time, in this variable I use the same variable. In this variable I also add this code. Okay, so in this time what to do? In this time, for the LST modis LST, I can got total 598 images. This 98 images is multiply with my scale factor all of those images, and also subtract this value 270.15 because I need the result in degree Celsius. So when I can get the Kelvin value, from this Kelvin value, when I can subtract with the 273.15, then it will be, we can get the result in degree Celsius. Okay, this value is the mainly conversion from the Kelvin to degree Celsius. Okay, and this property I copy from image system time. So now in this time I just run the again, because in this time I can get the proper result in degree Celsius in the time series chart. Okay, so now we can see the result about that. You can see for that we can get this chart look like that. Okay, here we can get the data set about, you can see year of 2010 to 2022, all of those data set we can get in here. Okay, this chart is not meaningful. In this time, if you want, you can add here the chart title, X level title, Y level title, leveling. You can easily level all of the chart, styling. So for that, what can we do? Just we can simply use here the, suppose I want to add some option. Okay, so for that I can simply use here this function called the set options. Basically this set options is a function. This function add this chart some other option such as chart title, Y level title, X level title. So this type of option will be set with the chart. So I want to add here the, suppose, title. So for that I simply use here the title. I put the title, suppose LST. Time series chart 2010 to 2000. What's the value? 2020. Okay, 2022. Okay, so I put this chart title look like that. Then also put the another thing is that it's called the vertical axis. So vertical axis, I put at the vertical axis and put the vertical axis title is that, suppose it is the LST degree Celsius. Okay, then put at the Y level title or X level title, it is that horizontal axis. So H axis or horizontal axis, put here this title such as this is the time. Okay, so now click to the run. Now check about the result. Okay, in this time we can check the chart is not meaningful. Again I check, I add here this, but I can take some line break. You can see it also break, also break, also break. Okay, this chart is not meaningful. Okay, because it's showing the break. This type of break we can easily remove and also get the continuous line chart. For that we also need to use the another function, it called the interpolate nulls. So I simply use here this function. You can see first time there is no problem, but when I add the title, then the chart will be line break. Yeah,
one quick question.
yeah, please.
So this chart is for all the pixels from the region, the Dhaka region,
Yeah,
and this is showing the surface temperature of all the pixels in the Dhaka region, right?
8 days average all of the pixel value for the LST whole country bound whole city of Dhaka.
So, for example, there are say 1000 pixels in the Dhaka area. So, it is taking the average of all 1000.
Yeah, and it will
For
be
that particular
grid size
time.
is that suppose 1200 into 1200 in this grid. What's the value in 8 days? It will be extract that this pixel.
1200 kilometer by 1200.
Yeah.
So, Dhaka city must be maybe just 1 pixel,
Yes.
right?
Yes.
Okay.
Okay. So in this time here you can see the chart, we can get the some line break. So in this time we need the smooth line. So that's why this chart will be continuous line. Okay. So for that, what can we do? Just we are using a function interpolate nulls. So in this time, I simply write here. Suppose I simply use a thing is that.
Okay, can you print? Can you show the map of the one of the years for the Dhaka city?
Okay, map. Okay, so after completing that, I'll also try to show the how can easily display the map. So in this time chart, we can get the how can get the proper chart. Okay, not only for that, you can also work for the in the chart. Lot of time you can get the some line breaking. Okay, you can see this type of line break you can got. But using a function, we can easily remove this type of line breaking and also get the better chart. And this chart we are easily using for the different types of paper or other things we can easily use. Okay, so for that, okay, so I simply use a function. This function is called the interpolate null. So put here interpolate nulls. Okay, and then mention here a function. It will be just put here the true. Okay, so just use here the interpolate nulls and use here the true. Then this type of line breaking will be removed. So click to the run. Now let's check. Okay, so now we can get the smooth chart. Okay, I add this all of the things and also get the smooth chart. That is no problem. Okay, suppose I want to display the chart for only for the 1 year, then it also better. Suppose I will put here the suppose year of 2020 from 1st January from December. Now let's check about the time series chart. In this time I can get the chart look like that. Okay, but when I want to remove this function, suppose I did not use the interpolate nulls values, I simply commenting this. In this time you can see this chart, I can get the some this type of breaking line. Okay, you can see this type of breaking line and got in here. Okay, but when I use this interpolate,
that means for those time either images are not available, right?
Yeah.
That's the reason there is a null value.
Yeah. But when I put this interpolate null values, then it's automatically displaying this type of chart we can get in here.
Okay, so Sachin, you understand the interpolate, right?
Yeah, interpolate. Yeah. So interpolation, suppose using the interpolate, we can easily find out the unknown values for any specific region. I can get the some, suppose 1 or 2 value, then third value I can easily get using the interpolation or IDWI technique, which I use the ArcMap or QGIS software. Same technique you also behind on here. Okay. Okay, so this is the process for removing the line break. Okay, we can easily remove the line break using the interpolate. Just open it as a true function, then it will be removed. In this time, suppose you want to add the color, you want to change the color about that. So what can we do? So for changing the color, we need to use another argument is that series argument. So put here the series and then make a dictionary. In this series dictionary, just 0. Why I put the 0? In this time the chart is only showing the one line. Okay, one line. Okay, so JavaScript is a 0 base, so this line consider as a 0. But when I want to add suppose other types of line in also in here, then 1, then 2, then 3. So first it will be start from the 0. So this it is the only for the one line, so that's why we are using here the 0. Okay, and I mentioned the color about that. So put here the color. Suppose I put this color as a green color. Okay, and I also need to put here the comma sign also in here. Then click to the run. So in this time it will be showing as a result about the green color. You can say I can get the result in green color. Okay, and also change it as a green color. Okay, as well as if you want, you can also check about the trend line. Suppose in this time I want to get for suppose this year, not only for this year, or whole the 2010 to 2022, what is the trend about the LST. It is the high trend or low trend. So that's why you are also making the trend lines in here and also get the result about the trend line. So let's go about that how we can easily do that. So for that, I just simply for the trend line and use at this comma sign also. So comma sign, and we can also show the R square value. R square value also show about the trend lines for the R square value. What is the relation or R square value? We can easily display the result and also in here. So for that, I can simply use a thing is the trend lines and then make a dictionary. In this dictionary, I want to make the trend line using this line, okay, using this graph, and there is only for the one graph, and it will be 0, okay. So only one graph, it will be 0. So for that, I can simply use a function 0. It will be because this is the number of 0, number of line, so 0, and then make another dictionary. In this dictionary, put all of those argument. So first of all, we need to make an argument about that. Suppose color. What's the color you want to put in here? Suppose you want to show the line trend as a red color, so then you can simply put here this red color. Suppose I put here this color and put here the red color. After that, suppose I put here this another thing is that I want to show this straight line chart as a linear. So for that, I can simply put here this another thing. Suppose use the comma sign and then put here the suppose type. I want to show the straight line chart will be linear. So put here this type and put here the linear. After that, I want to show the result about that. Suppose line width. So put here the line width. Suppose I put the line width is a 2 pixel. Okay, put here the 2. Then after that, what's the argument get? Suppose I want to show the result about that. Suppose R square value and to show. So for that, I simply use at the show R square and then put here the true. Okay, then it's showing the R square value, as well as suppose I want to add here the also showing the legend about this trend line. So use at the visible in legend, okay, and put here the true. Okay, so visible in legend, I put it the true. Okay, so this is the some types of argument I simply put in here. And now check about the trend line about this time series chart. So let's go. Why? I check the spelling. Suppose visible, visible in legend. It will be true. Okay, then color is red. Type is the linear. Line width is the 2. Short square is that. Okay. Okay, so visible trend. I think it's also maintain the, and then put here the type. After the type, I put at the color. Then show. Okay, now let's check. Okay, so in this time, okay, so it will be just lowercase, okay, not uppercase. So now it will work. Yeah. So it will be lowercase, straight lines. Okay. So now you can see it will be displayed about the trend line about that. We can see this trend line is the upper, okay, not lower. So it's showing this result about that upper. Okay, so it means that for the Dhaka city in the LST or land surface temperature, in this time period, year of 2020, day by day increasing. You can see the result about that. We can get this is the R square value. Okay, LST R square value we can get in here. Okay, and this is our, you can see in this time we can get the upper. This straight line is showing is the upland, no lowland.
So, Mijanu, so I got this point. So,
Yeah.
if suppose we want to analyze uh, for last 10 years,
Yeah.
only for say summer, means say just say April to June,
Yeah.
3 months. Can we do that? How can we do that?
Okay. Okay, so in this time when you want to, suppose in this time, so for filtering the image collection, there are lot of way. Suppose you want to need only for the, in this time we can randomly put this time. Suppose in this time you want to filter only for the summer from year of 2000,
April, May, only for 3 months.
only for the
April, May, June, and last 10 years.
April, May and June,
Hmm.
and last 10 years from year of
10 years.
2010 to 2020, suppose.
Yeah, suppose, yeah.
Okay, so this type of, we can easily get this. So for that we are also need to put the another code such as filter calendar range.
Oh,
Okay, so you can see this function calendar
DR. AR.
okay, calendar, yeah, DR, yeah, calendar range.
Okay.
So we are also need to use this type of function filter or calendar range. In this calendar range we can easily filter for that specific time period. Suppose you want to need only for the 3 month and for the 10 years. Okay, so this type of analysis we can use this and also try to filter our specific time period about that. Okay, so I also give you the practical example, then also better. Okay, so we need to use here this function calendar range function, and then filter about the specific suppose in this time you need the data, suppose June to August, as well as suppose you also need to data about that year of 2000 to 2021. Okay, so let's go about that, we can check about this. So in this time we use a function is that in not filter date, we are using the function about that filter range. Okay, so put here the filter, and I want to filter dot filter dot calendar range. Okay, calendar range, and then also closing that. Okay, and then you can check about that argument. So start, end, and field. So for that, in this time, suppose, okay, for suppose you want to, suppose you need the data set about only for the month June to August. Okay, June to August you need June to August. So I'm simply put here the, it will be start from the June, suppose 6, and then suppose August it will be 8. Okay,
8.
and then suppose field, I can simply put the field such as a month. month. Okay. In this
Oh,
time, what happened?
got it.
I simply click to the run again and then check
No,
the
but
result.
where is your date, that 10 time period?
Yeah. In this time, this data set is showing the full. Suppose it will be start from, you can see year of
I, I,
2000 to 2000.
I got that.
Yeah.
So it's for the 598 images itself,
Yeah.
right?
Yeah.
Or the full. Yeah, okay.
Yes. 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 Then we are also use here the filter date. Then we can get the result, specific images, and also
Oh, okay.
check
On
about
top
this.
of that, we can use the filter date. Okay,
Yeah.
now I got it.
Yeah. Filter calendar and it's specific, we can put and can get the result. And now we can check about this time period chart, look like that. Okay.
Hmm.
And also we
So
can
this
get the
is
all of the
interesting
things.
for me, right? In 2006, it went down.
Yes.
Temperature went down too much, like as compared to the trend line.
Yes.
So I think there is something wrong here, right? This cannot go
Yeah,
that much
basically it is the
down.
resolution. Suppose this is the, it's not a high resolution, so we can get the 1000-meter extract the information. Okay. So but when you want to work with the
Hmm.
Lancet, then we can also get the very better result about that.
Oh, now I got it.
Yeah.
Okay. Then in this case, that's what I wanted to see actually. The difference, like if we are using Modis or
Yeah.
whether it is Sentinel or
Yeah.
Landsat, right? So,
Yeah.
uh, like which one is the better? Which one gives me the better result here?
LST
Right?
for that better is that Lancet and Sentinel 3. Sentinel 3 is also
Hmm.
more better. Sentinel 3 is also
Hmm.
possible to create that. Sentinel 3 is we can also get the data from the Copernicus also for the LST
Hmm.
band as a
Hmm.
Kelvin for the Sentinel 3. Lancet is also available. We can also get the Lancet image, also get the very long or very past time year of 1990 or 1970, 83. So this type of period we can easily extract the information about that LST from the
Hmm.
Lancet. But Sentinel 3 is
Oh,
available from the 2015 or 16
okay.
this time period. Okay. So in this time we can see we can get the result look like that. And this is the process. Okay. This is the process for creating the chart. Okay. So first of all, UI
Hmm.
chart image dot series, put that. You need to create the image collection. Put this image collection variable name. Then which area you want to need that. In this time you can easily change the area. Suppose I simply remove my Dhaka city area. Suppose this is my region of interest. Suppose okay, so suppose this is my region of interest. So for that, what can I do? Just I simply draw a shape. Suppose this is my area. I simply draw the polygon about this area. And for this, I want to check about that what is the trend about the LST. So I simply change the name as the ROI. ROI. So now I can get the result about this region. So now let's check about this. Okay. Okay. We get the result look like that. I think there is a
Hmm.
not much very change about that between this time.
It's almost a
Yeah.
yeah, straight line. But it's for we haven't given the date range here, right? So it's for the entire data.
Yeah.
But we need to find out how much is the surface.
Yes.
So this is for the surface temperature, right? So do we also have something for the water temperature?
Yeah. For the water temperature, Moody's has a possible about that some aqua satellite imagery such as water. When you want to about the
Hmm.
water temperature, they also provide some aqua. Moody's
Okay.
aqua LST is also available. And for the Landsat, we are also take the data about that water or natural feature such as vegetation or forest.
Hmm.
There are also another equation about that Landsat. Landsat,
Okay.
suppose natural and build up or urbanite island. So this type of region has some different equation for calculating the
Hmm.
LST. Okay, so I also
I
try
have
to
a
show you that
question.
about that.
Is
Yes.
it generating the right data? Because when you selected Denver area, which is very, very cold,
Remote
right?
sensing data is not accurate 100%, is not possible to provide, but
Because 30
almost
to 40
same.
degrees,
Yeah.
30 to 40 degree is not what the temperature in Denver is.
No, but this is for the specific months, no, Sachin?
This is for which
This
months?
is for June, July, August, 3 months.
Yes, 3 months.
So it's a summer time. It's a
Uh,
summer time.
Yes,
so okay.
So this is summer time, right? So
Mhm.
it's 30 degree. Sometimes it's going above 40, and I think that's what he clarified, right? So land Moody's is not that accurate. So we need to find out the way from the Sentinel or Landsat.
yes,
So this is on Saudi Arabia. This must be around 40s, 40, 50s.
yeah,
Yeah,
50.
see, 50s. I think, yeah, this is okay, kind of a range for that particular region. You
Okay,
can go to the Canada region, Canada,
okay,
search for Canada. See, I think Canada should be even lower than Denver. Denver was in the range of 30s, right? Sachin? Summertime again.
Yeah,
It's just above the North America.
it is very cold in summer months. Also, the temperature does not go far like 40 or something.
I think, no, yeah, not more than 40. Yeah, take some region here.
It's too big.
okay.
It's taking too much time. Looks like it's very cold there.
I think this is a peak region.
Yeah. Uh, 276. Yes. So surface temperature, Sachin, is a very important aspect of from the ESG standpoint, yeah, environment standpoint, sustainability standpoint, because that's what people are now looking like. If surface temperature is showing the increasing trend, then we can go deep, right, and check what are the factors that are causing that increase. That's the reason we have this global warming, right? Especially the water temperatures.
Yeah, and
Because of the surface temperature is increasing, we are producing more carbon, and that because of that surface temperature is also increasing, and
Okay, this
water
is
temperature
right.
is
Yeah.
increasing. Now we got it. Okay, so it's in the, yeah, we were in the right assumption. It's in the range of 20 to it's between 30 to 40.
perfect.
Sorry, yeah,
This is
25.
yeah.
This makes sense.
Yeah.
But you can still see summertime. In 2009, it went down to almost like 10 degrees. That is also unpredictable kind of a thing, right? And if you see, like many times that's happening. But summertime we can we understand, even if it is a colder region, we understand summertime should be little high, which as per our understanding in the range of 20s. But sometimes it's going down.
Sometimes it rains and the temperature goes down, or probably that may be the reason.
Yes, could be the reason. Yeah. So can we see this data in the map at that particular region?
Yes.
You know,
Yeah.
show that in the
Yeah.
map
For
now.
showing
For
this,
keep,
okay.
yeah, keep
Suppose,
the same
okay, so I
area.
simply imported the shapefile of Canada, then it's also better, we can get the better result. So for this Canada shapefile, I simply use the US device website or dataset. I simply import that and filter the Canada shapefile boundary. So for that, I simply take a variable in here. Suppose uh, Canada, then call the table. This table just filter. Then how I can filter Earth Engine filter dot equal. What's equal what? Put at the country NA Canada. Okay, so now Canada shapefile is stored in this variable. So now I want to, in this time, this image collection I need to reduce. Okay, for displaying the result. So for that, what can I
Hmm.
do? Okay, so I use at the ROI. Then it also better because we are working with the ROI for creating the time series chart. And first one, I simply remove that. Okay. So now I simply reduce this image collection and display the result. In this time, all of those images, total 276 images, I want to display the result as a suppose
Mean, okay.
mean result. Okay, and display the result. In this time, we
Hmm.
can see what the problem. Error generating chart, no image in the collection in intercept in the specific region. No feature content null values.
You have to remove that interpolation.
I think about that. I check. Okay, I use the country code. Sometimes spelling also will be not accurate. Then I also face the problem about that. So okay, CA for Canada. Okay, I can put the wrong spelling in here. That's why it is like that. Country TRY. And now check. Okay, so I hope now it will work, but need some time. Okay, so now in this time we need to reduce this image collection. So for reducing, we're using it the min function. So take a variable, suppose average LST, and then call our image collection. These are image collection. We already reprojected and also change the unit. So put here, use at the reduce function and put at the EE dot reducer dot min. Okay, and also click with
Hmm.
our shapefile. Is that ROI? Okay,
All right.
so now display the result. So use here map dot and call this variable name and click to the run. Okay,
So now in this case, there are two processes running parallelly, right? One is generating a chart and the other one is now
yeah,
creating a map for us.
yeah. So map is appeared, but it showing look like that because we did not add any visualization. Okay, so
Hmm.
add the visualization. So now in simply okay, so they already provide some demo code, but we are just changing about that minimum maximum temperature. Okay, I simply copy that. Okay, and then paste here. And now I simply, what is the minimum temperature for this Canada?
Hmm.
Okay, so not accurate value, just almost near to this value. What's the negative? What is the value for that near minimum temperature? And it will be negative or positive. I don't understand about that. Okay, so I simply use that was minimum 10 degrees Celsius and up to suppose put here suppose 25 degrees Celsius. Okay, so according to this range I want to
Mm.
use and then try to show the result, what result we can get. Then simply copy that and paste after the object name. Okay, in this time which map will be display, it showing the range between that 10 and 25 degrees Celsius. Red color is that showing the 20 or 25 degrees Celsius. Okay, and this type of is showing
It's so
the
huge.
low
Oh man, it's
temperature.
so huge. And during summertime, this is okay. This is mean, right?
Yeah,
I mean,
mean, yeah.
we reduce it, and this is for entire year, right?
Yes.
Okay. So, but still, like,
So I check the value from here. Suppose this value is that almost 2.25 degree. Okay. Okay.
mm,
So we are also use here. Suppose minimum. I put here the suppose.
minimum you can use zero, man, or even negative, minus 10,
Okay, minus 10,
and do minus 20. In some regions, you will have minus 20 also.
minus 20, and maximum
Yeah. Maximum can be for let's say put 14.
by 31. You can get 30. Okay, for use at the 40.
Now you will say less red area. Yeah.
Okay, so now it also look better.
Mm.
Okay, but in this time, you for this suppose for this region, what is the exact minimum and maximum value? When I download this image and import the ArcMap
Mm.
software, it automatically showing
Mm-hmm.
what is the low, what is the high value, automatically display in this
Okay.
ArcMap software. Okay, and according to this
Mm.
range, we are using here the different types of color and display the result. Okay, and also generating the time series chart. But we are face some problem when it will be
It's a large region,
large
right? So
large
you
yeah,
don't.
large data set and large area, so that's why sometimes it also problem. Okay, so in this time we also reduce the image collection. Suppose I simply use here that suppose here okay, so I use the filter date and then check the time series chart.
Yeah.
So we have the filter date, suppose year of 2023 1st January from year of 2023, suppose here 05 05 30. Suppose this time you can check about that. You can get only for the 19 image collection. And for this time, what's the maximum value? You can check 10 degrees Celsius, 7 degrees Celsius, minus 25 degrees Celsius, minus 50 degrees. Okay, for the better result, we can simply change here the suppose visualization minus 25. And for this, you can see for this, I also take it. It's showing as a 11. Suppose put here this 15. Now we can also get the better here. 15 degrees Celsius. So this is also this is the minus 25, minus 15.
So red ones are around in the range of 15.
Yes. Okay, so this is the process for displaying the result and also showing the time series chart about that. Okay, for the LST and all of those data set, we are easily applying the same process. Not only for the MODIS LST, they are also provide the MODIS, so you can also get the evapotranspiration data set, also NDVI. Okay, all of those data set is the same process for visualizing the display the map as well also visualizing the shape time series chart about that. Okay. So in this time, we already discussed about the Landsat imagery, and in this time we will also try to discuss about the some application of the Landsat as imagery, such as different types of time series chart, how we can easily create, as well as how we can easily create the different types of suppose indices using the Landsat imagery. Okay, so here we can get all of the things about the Landsat 9, Landsat 8, Landsat 7. Filtering process is the same. We already discussed about the filtering and visualizing the image. So today I also try to show you that how can easily create the time series chart about the Landsat 8. Suppose you want to use the Landsat 8 for making the NDVI map, and now you want to calculate the time series chart. Okay, so for that what can we do? So first of all, I simply suppose mainly indices we are creating this from the top of atmospheric imagery is better for creating the different types of indices. So I simply click on here and we can get all of the information. Okay, so first of all, I simply copy the image collection from here and then make a new code editor. And paste. Okay, then give a variable name, suppose L8. So now this L8 I need to filter. To take a variable, suppose image. So I simply call the full collection L8 and use that the filter bounds. Okay, so in this time I simply take a marker. Suppose this is my area of interest. Okay, I simply put this marker name is that ROI. Okay, so now I just simply use at the ROI, and now I want to filter it. So first of all, I simply use at the filter date function. The filter date function I simply mention start date and end date. Suppose I put this time period such as year of 2000 to end it to 1st January from year of 2022 December 31. Okay, so in this time year of 2020 for this region I want to find out the lowest cloud cover image. What is the between this time between the year of 2020 when I got the very lowest cloud cover image. Okay, so for finding that we need to use a function, this function called the sort function. So when you want to find, suppose I want to find out the lowest cloud cover image for this region and what the acquisition time period of the lowest cloud cover image for this region, I want to find out this date and also need this image. So then we are sorting. So use at the sort. In this time I use at the sort using the cloud cover. I need the lowest cloud cover image. Okay, so I sort according to the cloud cover and then take the first image. In this first means that which is the lowest, it considered as a first. Okay, now let's check about the image information. Simply print the image and then click to the run. In this time I can get only for the one image, and this image is the lowest cloud cover for this region. I want to check acquisition time is that you can see year of 2020 2307. Okay, this time period is that lowest cloud cover image I can find out. I want to check what is that lowest cloud, all 0. Okay, so for this date we acquisition time is that for this time I can get this image and this image is the cloud cover is the 0. Okay, So I check the another region. Suppose I simply click on here and drag it another place. So for this region, what is the lowest cloud cover? I want to check it. So simply click to the run again. So now it will give the information about you can see year of 2020 0803. This time I got this image for this region is the lowest cloud cover. And what is this? You want to check almost 0.04. Okay. Suppose for any region you want to need the lowest cloud cover image, then you can also filtering according to the sorting. You sort according to the cloud cover and take the very less cloud cover image. Okay. So any region you can easily get. Suppose in this time you want to display the satellite image in here. For this reason you want to display this satellite image. So what can I do? Just I simply use here the map dot add layer function and call this image and click to the run. So now this image showing as a tiles. Okay, you can see it showing as a tiles. Okay, and this tiles is that acquisition time is that year of 2020 0308, and this cloud cover is that 0.04 lowest cloud cover between this time period year of 2020. Okay, so now I want to add here the different types of band combination. Okay, so basically band combination we can just add the three band create a one combination. Suppose in this time I simply click on here and you can see B1 B2 B3. So different types of band combination we are using the remote sensing and extract the different types of information using the different types of band combination. Okay, suppose in this time band combination for red, B4 is called the red band, then B3 is the green, and then B2 is that blue. It also called the RGB, also called the true color, also called the natural color band combination. Okay, and also increase the 98% for better looking this reflectance range and also apply that. So now I get this image the true color composite, or also called the natural color band combination. Okay, natural color band combination it create about this. Okay, and in this time I showing that natural color, this is the vegetation. Okay, green color as a vegetation. Also get, you can see this is the build up area in here. Also you can get the water body. Okay, all of those nature, all of those feature we can easily identify in this time from the satellite images. Okay, this is a build up area. Okay, so basically this band combination is the true color composite or natural color. We are also different types of band combination we are also providing here. Suppose another band combination is also called the near infrared band. B5 is the near infrared. Then put here the B4 and put here the B2 also and apply. So now this band combination is also called the false color composite. Okay, so mainly this false color composite, when we are using this type of band combination false color composite, then we can get the water body as a black color. Okay, this type of color we can get, and vegetation will be red color. Urban we can get this type of white color. Okay, so different types of band combination identify the different types of information from this satellite images. Suppose I want to use there the band combination such as shortwave infrared 1. Shortwave infrared 1 is that B10. Then near infrared is that B4, and then put here the green. So mainly this band combination is very useful for monitoring the agriculture field. It's not okay, it will be, I think it is a shortwave infrared 1 or 2. Okay, sorry, near infrared band is the B5 for the Landsat 8. It will be B5. Yes. Yes, now we can get this type of result. In this time you can see water body showing as a red color, barren land showing as a brown color, and it is a vegetation. Okay, so we are using here the suppose B4, and from this we can easily select all of those band combination B3 and B2 and apply. Okay, so it's showing as a natural color band combination. So now I import this band combination. So just simply click to the import. So it will be imported, you can see, and then give a variable name. Simply copy that and paste after the object name. Okay, and put the layer name, suppose NDVI. Oh, sorry, it is the suppose natural color. Now this color band combination is set with my code. So now I can get this satellite images. This is the acquisition time period. So now I want to make the suppose NDVI map or land use land cover classification map or other types of remote sensing work we can easily do. But for this image is not possible to create the time series chart because it's only for the single image. When you want to make the time series chart about this, you must be need a image collection. Okay. So first of all, we try to show you that for creating the NDVI or the different types of method we are using for get the NDVI result.
Vijanu,
Yes.
Can we take land surface temperature LST here?
NDVI, yeah, land surface temperature is also possible for creating the NDVI or other types of indices. But mainly different research paper I also show you show that it's showing that the result they are derived from that land top of atmospheric for indices result, and get the result for the land use land cover, get this result from the surface reflectance. Okay, but we are also do for that indices also use the surface reflectance image is also better. There is no problem, same process. Okay. Okay, so now we can get this image. So from this image I want to extract the information about the vegetation greenness. Okay, so vegetation greenness I want to extract from here. So for that, what can I do? I need the help of NDVI. Okay, NDVI, and NDVI formula is that near infrared band minus red band divided by near infrared band plus red band. So this is the formula for creating the normalized difference vegetation index. Okay, so now I want to use this in NDVI, and after that I also try to make the time series chart. But time series chart is not possible for the one image, so that's why I also take between the year of 2020 all of those images I get. Suppose less than 1% cloud cover, all of those images I got and make the one composite, and then we are usually make the time series chart about that also LST. So in this time single image we are using and then make the NDVI. Okay. So now there are a lot of way for calculating this type of equation. Okay. So first way is that it's called that function, normalized difference function. Normalized difference function. Okay. This function we can directly use and then calculate the indices. So for that, what can we do? Take a variable, suppose NDVI, and call my image. This image is stored in a variable image. Simply call this image and paste here, and use a and simply use a suppose use a normalized difference. NCE. Yeah, normalized difference is a built-in function. This function has already defined how it will be calculated. If you want to simply copy this function and then click on the docs tab, paste here, and check the result about. Okay, check the result. So compute the normalized difference between two bands. Suppose in this time near infrared band and red band. If the bands to use are not the specified, use the first two band. The normalized difference computed as the first minus second, first plus second. So in this time, first minus second, first plus second. In this time, which band I mention here the first. Suppose I mention here I need the near infrared band B5. Okay, and second band will be B4. Okay, then it will be calculated the near infrared band minus red band divided by near infrared band plus red band, or first, this is the first minus second divided by first plus second, computed automatically. This equation is computed. Okay, and this equation you can see almost same in here. Okay, and this normalized difference it's only work for two band. Suppose you can also same equations such as EVI. Suppose you can see the EVI equation is that EVI or SABI. Okay, we try to SABI is that soil adjusted vegetation or SABI. Sub index formula you can see it has also some a constant value. You can see band 4, band 3, and also constant value 0.5 and 1.5. Suppose I simply copy this equation of Savi. Soil adjusted vegetation. Okay, it's showing the Landsat 4 to 7, but I want to use the Landsat 8. So this equation is the different for the Landsat 8. Okay. So just I simply show, you can see for the Savi, yeah, for the Savi Landsat 8 and 9 equation will be that. Suppose this type of equation, when you want to calculate it using this function, it's not possible. Okay, this function is only work for that 2 band. Okay, where we can get the 2 band, then we can easily calculate that. But you can see Savi has a 2 band is available, but also some constant value. Okay, and also some other constant value, and it's also not follow this equation, first minus second divided by first plus second. This equation is not followed. So that's why we are for that we are also need to apply the another types of function. Okay, but when you want to work for the only for the 2 band, then simply use the normalized difference and put the band name. So now it calculated the NDVI. So simply put here this map dot add layer and call the NDVI. So now it calculated the NDVI. You can see the result. Another level will be already answered in here. Okay, but this result is not proper because I did not add the visualization. So I add the visualization. Suppose it will start from the -1 and max up to +1. Plated, I simply put at the plated. It will be negative pixel value showing as a water body. Greater than negative value, it will be showing as a white color, and vegetation showing as a green color. So let's go about what's the problem. Okay, use here the comma sign. Okay, so now you can easily identify about that. You can see vegetation is showing the green color, water body showing as a blue color, and barren land or build up area showing as a white color. Okay, if you want to check the value for the vegetation, you can see I simply click on here. So now I can get about that pixel value about the NDVI negative 0.63. For the water body, pixel value always showing the negative. You can see here this layer name showing as a ND. Okay, but we are also change the name ND. Suppose I want to put here the NDVI. Okay, so for that I simply use a rename function. So use here the rename, and this rename I put here the NDVI. Okay, so now it will be okay. You can see. So thus I simply check the value. I get the value 0.63. NDVI value 0.63. You can see for this point. Suppose I want to check the dense vegetation, I can get the highly positive value 0.5. Also you can see the 0.7. Also you can see 0.8. Okay, so densely vegetation is represented the highly positive value. Okay, and further you can take the suppose this white type of pixel value, it's showing the very low positive value. Okay, you can see 0.06, very low. So it's very it can be barren land or also build up area, this type of result. But highly positive value, it showing the result about that step. Also you can see, you can easily find out this is type of the agriculture, I think the cropland or agricultural land in here. Using their shape, you can see this shape is the look like that, a rectangle or a square. Okay, so you can also use the NDVI and also extract the information about that cropland, and also extract the information for the vegetation, and also extract for the suppose densely forest. Okay, so this is the forest part. Okay, this it's not a cropland or also agricultural land, it's a totally forest. But in this time you can see, you can identify this type of vegetation, it is the cropland. You can see cropland, and we can also get the value 0.7. Okay, so this is the process for this vegetation. I can simply take this. If you want, you can also use here the specific boundary. Suppose you want to need the results. Okay, so I simply need the result for the Dhaka city. What can I do? Simply just use here this, import that, and remove the previous ROI and put here this ROI. ROI, and after that I simply clip with my ROI. So for that, just simply after this, simply use the clip with ROI. Now click to the run. So now it displays the result about the Dhaka. I also need to focus the center, so simply use that the map dot center object is that ROI, put here 10. Okay, so now it displays the result. In this time we can get the another problem is that you can see what is the problem you can get. In this time, for my region of interest in Dhaka city, which image or which tiles is that lowest cloud cover, this tiles is not fully covered. Okay, suppose I can get the which image, you can see this image I want to got year of 2020 16 February, but this image cloud cover is the low, cloud cover is low 0.01, but this image is not cover my full region, it has also some other part in here. Okay, it's not covered, so that's why in this time I not use this short function. So in this time I want to use there the suppose filter metadata function. Okay, because I need the full result. So for that, what can I do? Just I simply commenting this line and then use here the dot filter metadata and put here this cloud cover. I take all of those images which are less than 1% cloud cover, less than 1% cloud cover, and all of those images I just make a median composite, median, and then click to the run. So now it will be work fully. We can get the result full part. Between this, all of those images created the one composite of median for this region and create this map. Okay, so now we are also make the time series chart about that, because it's not create about only for the one image. Okay, it create the image collection. Suppose all of those image collection I create the median composite and display this result, but it backend has more than one image. Okay, how many images? Then I calculate how many images are available. So this is my image collection, and then using this image collection I just create about the time series chart of NDVI, and using this time series we can easily identify when the NDVI is the high, when the NDVI lows between this time period. Okay, so any question in here for that?
If I want to calculate some area for specific vegetation type, for example, crops.
Yeah.
How much is the crop and how much is the forest?
So it's our part of our classification. Okay, so for the classification you can classify the crop and classify the forest, then calculate the how much area about that classification, how much area for that crop, it also we can easily identify. And we are using here the different types of method for identify the cropland or identify the forest land. Okay, this type of land, when someone such that I also try to show you that in this USA we can easily find out this is the forest. Okay, and also the dense forest, we can also find out the cropland. We can get the some structure such as a rectangle or this type of structure we can get, or a square is as a cropland. We can take the training point from here and then classification and classified the area for the cropland and agricultural land or vegetation, then calculated the area.
Okay.
Okay, so you can see here we can easily calculate it, this type of equation for that which are only for the two band. Okay, but which equation has that more than two band and also have some other constant value. In this term, this equation is that NDVI minus NDVI 4, NDVI 5, band 5 plus with band 4, 0.5 multiplied with 1.5. Okay, so this type of equation, when you want to calculate that, you need to use a function, this function called the expression. So we need to use at the expression and then calculate this type of result. Okay, so just we are take the break for the 5 minutes and then we start. Okay, for this 5 minute break, just 5.
सचिन तुला कधी का टाइम आहे दुपारी?
दुपारी का